Well, we're doing question 6. Question 6 says the diagram below the graphs of f of x equal to sine x, sine bx, and the g of x equal to negative cos x are drawn for negative 90 degrees lesser than or equal to x lesser than or equal to 90 degrees. Use the diagram to show the following questions. Okay, here the diagram, and then the questions are as you can see. And now we're going to do question 6.1 that says write down the period of f. Okay, a period for trigonometric functions are the complete length of a cycle. Like if we look at this diagram over here, it makes a complete cycle or a cycle. Okay, this is a cycle from there to there, a cycle because it goes up to the same height. Okay, they all have the highest value of 1. Over here also, these two, it makes us a complete cycle here. Okay, and then similarly over here and there, it makes also a complete cycle. Now, let's see how many, the period then will be the length of a complete cycle. So it will be, if I consider looking at this from negative 90 degrees to 30 degrees, you can do calculations by saying, okay, to find the length, it's going to be like, I'm doing 6.1. To find the length, it will be like 30 minus negative 90 degrees. 30 degrees minus negative 90, which makes 120. If also we consider this distance from here to there, so we can just do 60, the highest, okay, minus 60 degrees, which is still equal to 120 degrees. Okay, 120 degrees. So even if we do, we look at this length to that one from negative 30 to 90. So we can just do 90 degrees minus negative 30 degrees. This is equal to 120 degrees because minus and minus here will make a plus. Okay, so we say the period. Therefore, the period here will be the period will be 120 degrees. Now comes question 6.2. The question 6.2 says determine the value of b. Okay, b. This is question 6.2. b is over here. Okay, we do have like sine of bx. Now we need to find the value of b. Okay, I'm gonna pick up any value in the graph here, like the top one here, that one. This means that sine of bx equal to 1. Okay, this implies that sine of bx is equal to 1. If sine of bx is equal to 1, this implies that bx is equal to 90 degrees. Okay, because a sine of 90 degrees is equal to 1. Now, let's look at the value of x for which sine of 90 degrees is equal to 1. If we look at the diagram here, it is when x is equal to 30 degrees, because when x is equal to 30 degrees, we have like bx is equal to 1. Now we say here, this is like b times 30 degrees, this is equal to 90 degrees. Now we can find let me draw a line there. We can say therefore b will be equal to 3, because 3 times 90 degrees equal to 90. 3 times 30 degrees, I meant to say. So what I did in calculations here, we had like b times 30 degrees equal to 90 degrees. Okay, and then what we did here, we divide both sides by 30. Okay, we divide by 30 and then by 30 there, so we get b equal to 3. B equal to 3. B is just a number, it's not a degree, so b is equal to 3. Thank you. And then question 6.3 says the general solution of the equation sin bx is equal to negative cos x, Rx is equal to negative 67.5 plus k times 90 degrees, or x is equal to 135 degrees plus k times 180 degrees, where k is an integer. Okay, k is an element of the z set, so which is the integer set. All right. The question tells us already what are the general solution. We can see that it's like this one or that one. Now we're going to use the general solution to find the value of the intersection. Okay, because that's what they ask. The question says determine the x values of the points of intersection of f and g for the given domain. So I'll move my code over here. Sure. So now we do 6.3. We want the value of intersection. Now we already, it is given in the question that x is equal to, it was can move there. In the question, it is given that x is equal to 67.5 degrees plus k times 90 degrees, or x is equal to 135 times k plus k times 180 degrees, where k is an integer, and then they want us to determine the values of x for the point of intersection of f and g. So move this one. So we're looking for the values of x, and then in the question it is given that x is equal to 67.5. Okay, the solution, the general solution, plus k times 180 degrees, no, k times 90 degrees, okay, or x equal to 135 degrees plus k times 180 degrees. Now, the values of intersection, we can see them also from the graph here in the question. You can see that there are those values, those ones, this one, and that one also. So we have like 3 points of intersection here. Okay. We cannot just estimate and then say it must be this, but we need to work them out. So now, what can we do then in this situation? Okay, I am going to move. Now we're going to look at the values of k. Okay, and substitute some values for k. If k has the value of 1, for instance, okay, I'm looking here. Let's say if k has the value of 1, then we'll have x is equal to 67.5 plus 90 degrees, which is like 1. If we can do it on the calculator. Let's say 67.5 plus 90. Okay, this is equal to, okay, we can see that it's 157.5 degrees. But this answer is beyond the unit, beyond the limit, because in the question here, it is said that x is in between 90 degrees, negative 90 degrees and 90 degrees. So 157 is already above, beyond the limit. You can also see the diagram. The lowest limit here is negative 90 degrees. The upper is 90 degrees. So we cannot take a value like 1. Or maybe let's take a smaller value. Let's say something like, I'm going to take a value of k. I'll take like a value for k. Okay, I'll delete this. Let's say k. Okay. Let's say k has a value of 0, for instance. If k has a value of 0, so over here we'll have x will be equal to 67.5 degrees plus 0 times 90 degrees. Because k is an integer, so we can sub integer values for k, and then this is equal to 67.5 degrees. Yes, this is one of the intersection points. If you look at the graph over here, so this is the 67.5 degrees. So this is one of the intersection points. So we need to find those other intersection points. I can sub in another value for k. So if I say if k, for instance, if k is has the value of -1, over there, we'll have like x is equal to 67.5 plus times 90, -1 times 90. Okay, that's the value of k, -1 times 90. And if you press this in the calculator, what we get 22.5. So we say, excuse me, -22.5. So this is the other intersection point. So we can see over there in the diagram, -20. Of course, it must be a little bit more than -30 degrees. So this is the other point. Now, over here, if I take another value for k, let's say if k equal to -2, I already can see by intuition that if k is equal to -2, it's going to be below the limit, because the limit is like -90, the smallest limit. If I do like 67.5 minus 180, okay, this is what I get, -112, which is lesser than -90, the lowest bound. So I cannot take k equal to -2 here. I'll stop there. Now, when I've stopped here, there is another intersection point. This one, another intersection point here. What can I get it then? Then I can use the other general solution over here. Okay, let's sub in a value of k. If I sub in 0 here, I know it's going to be 135, which is more than beyond the upper bound, which is 90 degrees. So I can take a value of -1. Let's see. If k, for instance, if k has the value of -1, we will have like x will be equal to 135 plus -1 times 180. Okay, -1 times 180. And if you work this out from the calculator, we do 135 minus 180. This is equal to -45. So here it will be -45 degrees. So now the solution of the intersection are, as we can see here. So we can write them in ascending order. If you want, we can say x is equal to 45 degrees, or x is equal to -22.5, or x is equal to 67.5 degrees. That's the solution. Thank you.